All right, we're doing 4.5, which isn't called creating vertex form, but that's basically what it is, right? When we're given questions like this and we have to graph it, we could make a table of values. Their x, y's, and a -2, -1, 0, 1, 2. Oh my gosh, this takes forever, okay? This is the worst method. It always works, but is really slow. So I'm going to teach you the faster method. So this is the big idea you need to know. General form, this thing sucks. No one likes it, okay? What you are going to do is you are going to transform every single one of these into vertex form. Vertex form is the thing we talked about last time, where you have something like this, okay? By looking at just these three numbers, you're actually able to graph really, really quickly because you can know the vertex. So I know looking at this, it's going to be that, okay? I roughly graph that in about 3 seconds. If I needed to do this with a table of values, it would take me like at least a minute, probably longer, okay? So to change it into vertex form, we're going to have to complete the square, which is that thing. Oh, I should write this down. Remember that thing you did last unit that you hated and you never wanted to do again? Well, it's back and it's super important, okay? So we're going to do the exact same thing. It's a little bit trickier and different because some people, when they completed the square, didn't do it when it was a function like this, where it's y equals or f at x equals. I'm going to show you what to do, okay? We are going to focus on these two things, okay? This number at the end, whatever it is, the constant, doesn't matter. Leave it alone, ignore it, okay? If you have a value of a here, something in front of the x squared, you must factor it. Okay, you always have to factor it to complete the square. So let's factor this one first. Oops, silly me. Okay. So I factored out the 2, so I divided those two numbers by 2, and this is what I was left with. Remember, this 24, I don't have to factor it. I can just leave it at the end. I don't need to factor it. Okay, now I know I'm good to go for the rest because there's nothing in front of the x squared. There's a 1, whatever. Okay, that's fine. So now what we're going to do, we're going to do our backward slash. Okay, whatever method you use to remember how to complete the square, this is my way. Okay, so it's like half, square, add, subtract. You take this number and you do these steps. So half of 8 would be 4, and then I need to square it, and I need to add it, and I need to subtract it. So the idea is like we did before, by adding and subtracting the same number, we're not actually changing the equation, we're essentially adding 0. But now, by looking at these three terms, okay, it's a perfect square trinomial that we can factor. So the only thing that makes this tough is that because we got this coefficient here, and this is trapped inside the brackets, we have to actually expand it before we can complete the square and do the rest of it. I'm going to do this step first and then complete the square. So I want to bring this out. So in order to bring this out, I need to distribute that times 2 onto this, okay? So I'm going to do it. Let's make a little bit more space for ourselves. Okay. Y equals 2, x squared plus 8x plus 4 squared. That's going to stay the same. When I bring this out, it's like minus 16 times 2. So it's going to become negative 32 plus 24. Yeah. Be very careful. The common mistake students will do is when they square this, they'll make it positive, okay? It's not negative 4 squared, it's negative of 4 squared, okay? The way I remember is that like this will always be negative. It will always be negative because this term was always positive. That's how we do it when we complete the square. Cool, so we got a minus out here. Great, awesome. All right, so now this perfect square trinomial completes and it becomes y equals 2x plus 4 squared, okay? I know it's plus because this was plus, and I know it's 4 because this was 4. If I had made it 16, it would have been the square root of that. It's 4, whatever. Okay? Then these two get combined, so negative 32 plus 24 is minus 8. And now looking at this, I could graph this pretty easily. I got my, the vertex goes down by 8, goes to the left by 4, and is stretched by a factor of 2. That's it, and now we can factor it. I'm going to do 2 more examples, but that's the basic concept. Okay, whenever you get an equation, you need to complete the square by doing the steps you already know. The only thing that's weird is this like plus minus stuff. So let's do 2 more examples. All right, this one's a little trickier because it's negative. It's going to work the same way. Okay. I'm going to factor out that negative 4 as my first step. again, that minus 2, I'm going to write it here, just don't even forget, okay? It goes at the end. I'm not going to do anything. So now let's factor out the negative 4. I get x squared. That sign's going to flip because it was factored by a negative number, and it's going to be an ugly decimal. So I'm actually, well, not that ugly. I'm going to leave it as a fraction so I don't mess it up and forget, okay? 9 over 4x. Cool. All right, now I'm going to complete the square in the same step because I can. Okay, so I'm going to do my sash. So half of this would be 9 over 8. Okay, that's half as big. Then I'm going to square that. Oops, sorry, no x. Then I'm going to square that, add it, and subtract it. Cool. Good. Okay. Now I'm going to distribute that negative 4 onto this, and then so I can move it outside the bracket. So, and I'm also going to complete the square in the same step because I can. So it's going to be x. It's going to be minus because we had a negative here, okay? Be very careful. Easy mistake to miss. This is going to stay 9 over 8, okay, as my shift. Again, this is going to be kind of ugly to graph because it's a fraction, but that's what it is. That's the answer, okay? When I shift this out, 9 squared is going to be 81, 8 squared is going to be 64, and when I multiply those by 4, okay. Well, actually, we'll write it this way so I don't mess up a step. 64 minus 2. Cool. Okay. When I multiply that out, it's going to become y equals negative 4x, oh, sorry, squared there, minus 9 over 8 squared. This actually becomes, when I deal with the fraction, it's going to become 81 over 16 minus, and I'm going to make this out of 16 too, so I can actually combine the fractions. So it's going to become 32 over 16. Then I can add these two together. It's going to become plus 49 over 16. Cool. Nice. So looking at this final equation, even though it's ugly fractions, we can actually see everything we need to see. We can see what the vertex value is going to be, and we can see the stretch value, and that it's going to be a negative downward opening parabola. Okay. The last example, same basic idea, but again, we got fraction. It's going to make it a little uglier to factor. I know I want my thing to be negative, to be positive x squared, so I'm going to factor out that negative as well. This could become just x squared. This term's going to be weird. It's going to be plus 6. Yes. Okay. The way I always check with fractions, because sometimes I make a mistake, I just double check quickly and multiply it. So if I did negative 1/2 times 6, would that give me negative 3? It would. So I'm good. That number is right. Okay. So now I'm going to do my sash to fill in the rest of this. Luckily, it's not as ugly as before. Okay. So we're going to do 1/2 of 6 is 3 squared. So we got 3 squared plus 3 squared minus 3 squared. Awesome. And that's great. So now let's distribute this to get rid of this negative and bring it outside. So this part is going to stay the same. Y equals negative 1/2. Let's complete the square, or perfect square trinomial here. So it's going to be x plus, because this was plus. And this is going to be 3. That's all squared. And then this, so we had negative 3 squared. 3 squared is 9. 9 times negative 1/2. Let's just even write that, just so I don't make a mistake. Oh, see, yeah, I did make a mistake. Negative 9, okay. Minus 8. When we do this math, this is going to give me positive 9 over 2 minus, let's do 16 over 2, and put those together. Probably could have done this in less steps, but the same idea. Negative 7 over 2. Yay. And that's the final answer. Okay. Those are 3 different examples. The same idea stays true. Now we'll look at it on the last one. Okay. This form sucks. No one likes it. Okay. We want to make it into vertex form. I call this vertex form. I think your book calls it like standard form. Okay. Vertex form because it gives you the vertex. To do that, we're going to complete the square. So we got to do our sash nonsense. We have to always factor out something to make it so x squared is by itself. Then we look at this term b right here, and then we need to do the sash to find out what two things we're adding, subtracting. Then we need to actually expand out and move that negative term out. Then we can perfect square trinomial awesomeness get our horizontal shift. Then we need to just multiply, a lot of times with fractions, to combine the two numbers to get our vertical shift there. That's it.